Good evening, everyone. Welcome to an enlightening session that promises to take us on an exciting journey through the world of geospatial data. We are delighted to have all of you here as we delve into a topic that has profound implication for our understanding of the world around us. Before we embark on this exciting journey, let's take a moment to introduce ourselves and set the stage for what lie ahead. Today we have HarshAditya Gaur as our estimated speaker for this evening. Throughout this session, Harshaditya will guide us through the fascinating evolution of geospatial data, from its humble beginnings to its role in shaping industries, policies, and everyday's life. Without further ado, let's extend a warm virtual welcome to HarshAditya Gaur, who will lead us through the fascinating journey of geospatial data. HarshAditya, over to you.
Hi everyone. Good evening, and thank you, Mansi, for the introduction. Hi guys. Today we will go around the journey of the geospatial data that we use, we consume, and we create every day in our day-to-day life using the app services that we use in our daily life, but unaware that in the background they are using the form of a data which is very different, which is very unknown to the common user. So we will go in the journey of that. So starting now, I will share my screen with you guys, and let's start the journey. So Mansi, is my screen visible too? Okay. Uh, so guys, let's move on to the journey. Before that, a small introduction of myself. So I am HarshAditya Gaur. So I did my bachelor's in computer science from JK Lakshmipat University, Jaipur. Then I worked for industry for some months, and then I got admission in the master's in Indian Institute of Remote Sensing, which is an autonomous body of ISRO, and from there I completed my master's in remote sensing and GIS with specialization in satellite image analysis and photogrammetry. And right now I'm working as a remote sensing engineer at BharatRohan Airborne Innovations Private Limited in Gurgaon. The areas of my particular interest which I currently work and which are my favorite topics, which I like, on which I work almost daily, on those are machine learning, geospatial programming, and hyperspectral remote sensing. So the agenda for today is the introduction to the geospatial domain. Then we will move on to the basics of the remote sensing. Then how the geospatial data flows from one level of processing to the end user to the validation and reporting stage, the, the flow of geospatial data. Then the use cases that can be built around that, and then the summary. So let's start the journey. So what is geospatial data? So let's break down this part into two forms. Geo, so it is relating to the earth. Anything that is relating to earth comes under the geo part. Then spatial, relation between objects and phenomena happening in a space and time. So any phenomena which is related to earth that is been happening in this part of space and time, that we call geospatial. The understanding of Earth's feature in the relation to their spatial context, such as attributes, measurements, or imagery. So any phenomena that is relating to the Earth, this can be anything: the pollution activity, the forest fire burning, any phenomena that is around, is we call it geospatial. Any location-based services that we use comes under geospatial part. So history of geospatial data, how the geospatial data we are consuming like from very early, since stone age, the people are using maps in the form of like stone maps. Then the people draw these sort of maps on the animal skin. Then the introduction to the paper drawings on the map. Then the miniature model in early 10th centuries. So these miniature models represent a man-made feature of the earth So these model also represent a form of a geospatial data. So from the early 10th centuries, you can see these miniature models representing a feature. It can be anything. It can be a man-made, it can be a natural feature, any feature. Then in the early 20th centuries, the aerial photography came into light. So in this form of geospatial data capturing, what happens, the people try to fly a kite, balloon, or even they like put these cameras on the birds and try to capture the photographs of their surrounding, and they try to analyze what's of the features they are getting from very far distance. And then this feature, this aerial photography evolved into what we known as remote sensing. So in the late 20th centuries, the advancement in remote sensing came. So remote sensing was there in these forms, but advancements came like satellite remote sensing became very famous. So there are two types of satellites that we use today. One are like communication satellites, and one are remote sensing satellites. These satellites can be owned by different uh, organizations. It can be owned by military, it can be owned by some private company. So these comes under different categories. Then the arrival of the GPS, which changed almost everything around us in the late 20th century. Then in the 21st centuries, what we are using is the web mapping and location based services. Your Swiggy, your Zomato, your every location based services that you are using currently are based on this geospatial data only. The maps we use are built upon the geospatial data. And the what future lies in the geospatial domain is the 3D and AR mapping. Viewing three-dimensional and AR map using our phones, our laptops, or any other gadgets that's available. So that is the future where the geospatial domain will lead further into. So we have different forms of geospatial data that we use every day. So this is an image. So this image is captured by an aerial platform. Aerial platform here means taken by a plane. So this is from the ISRO NASA Everest NG program. So this is of Jodhpur city, 3 meter resolution. So what here 3 meter represents is 1 pixel in this imagery is representing 3 meter of the area. So that's why its resolution is 3 meter. Then the very traditional form of geospatial data, maps, and then the documents. Documentation, it can be JSON, it can be a CSV, it can be an XML, it can be a Word file. So these form of geospatial data also exist. So in this particular picture, if you can see, we have lat long here. This is the type of crop, the name of crop, and the season with the year and a serial number attached to this. So you can relate it like that. Any form of information which contains lat long or any geographical location comes under geospatial data. So that's what I was saying. Every person is a creator and consumer of geospatial informations. So this leads to our giveaway for the session. So in this giveaway, what you guys have to do is explain in the YouTube comments how the transaction ID is a form of a geospatial data. And guys, please remember that chat GPT is not allowed here. So just I'm not expecting that you guys give me a very accurate answer, but if it's 50% or like even 60% correct, that you can be like enter for the you can be like a valid participant or a valid answer for this giveaway. So I'm again repeating it. Transaction ID is also a form of geospatial data. Explain in comments how. So, moving on to our next thing. So introduction to remote sensing. So what does remote sensing actually means? So here again we are breaking this down into two parts. Remote is like like you are at a certain location and you want to know about the uh, a particular phenomena or particular feature in the distinct place around you. So then sort of technique we use to gather information for that particular area is what remote sensing is. So with the diagram I will show you what is actually done here. So we are using sun's energy, and what the reflected energy we get here, it is captured by the satellites. So what we are doing here, we are capturing the phenomena that is happening on the earth via the satellites, and we are then getting this data to our servers, and from there the respective users download this data, and this is what actually remote sensing is. So the solar radiation, the reflected solar radiation, we captured it, and then we convert that this reflected radiation into DN numbers, what we call digital number, and then using those digital numbers, image is presented, and that we get output, and then further it is analyzed for various parts. I will introduce you how and what sort of imagery that we capture using these satellites. So first we need to go back into the physics domain. So bear with me for this. So this is what is the electromagnetic spectrum that we all have studied in our physics. So what we know is that from 380 nanometer to around 700, or you can say 750, is the visible range in that we can see everything around us. So we capture all this information from 380 to 750 and further to 780, which we called as an RGB, red, blue, green. But in remote sensing, what we do, we capture data not only in the RGB domain, but also far beyond that. We capture the near infrared, shortwave infrared, which comes under the middle infrared, till the thermal part, which comes under long wave of infrared spectrum. So this particular spectrum from 380 to 5600 is the region where most of the satellites capture. So it's not specific that every satellites need to capture this sort of information. It's up to the organization that how much information they want the satellites to capture, till what amount of this and wavelength range. So from here our journey starts of data, how we got the data, the acquisition stage, how data is being procured by various sort of platform, then pre-processing it, cleaning the data and doing all the pre-processing part, then perform a spatial analysis, then we model this data according to our use case scenario, and validation and reporting part. Reporting part is further divided into two tracks. I will like share more details for that. Let's go to the acquisition stage. So in acquisition stage, we have different types of platform. So I have discussed two platform like earlier, like one is satellite and I talked about aerial platform. So those are common platform here. But one of the trending platform that today industry is using, and it's one of the current trends, it's the UAV, the use of UAV platform for capturing remote sensing data. So UAV is not limited to remote sensing, but can be used for various sort of application. But today, primarily, it is used being for remote sensing. Then we have aerial, airborne. It's a synonym for that. So in this, we have a aircraft that carry the sensor, and a flight plan is being set before you go up in the air, and we plan whole mission, how much altitude would be there, how much speed would be there, and all these parameters are taken into account. Then only the aerial mission or the airborne mission is like planned. Then we have very common platform, that is satellite. So there are various sort of satellites. In India has various remote sensing satellite. We have RISAT, we have LIS, we have another military satellites which are not open to public domain, but we have very diverse sensor capability satellites in India, which can provide data in centimeter levels up to 30 centimeters. So imagine from space you are getting the 30 centimeter resolutions data. So it's a very like advanced satellites. What I can say, the list 4 is one of those. So types of sensor that I was talking earlier about, the wavelength and everything depends on this, what type of sensor. So first I will discuss about the optical sensors that are most common. So optical is nothing that but in this sensor what it does, it captures the RGB spectrum, the near infrared spectrum, shortwave infrared spectrums. There are very limited satellites that capture the long wave infrared spectrum. Uh, Landsat 8 is one of that. It captures in the thermal band, but optical region is mainly around this. So these sensors are particularly named as multispectral sensors and hyperspectral sensor. So difference between multispectral and hyperspectral is that the multispectral sensors are like basically it captures bands from 5 to 15 bands a multispectral sensor can capture. But whereas in the hyperspectral, the beauty of this sensor is that it can capture up to 250 bands, and the gap between those bands is very small, like 5 nanometer bands. Like interval between those bands is very small, very small. So today like every other country is trying to build a hyperspectral sensor, so they can like capture very detailed imagery with very fine spectral information. Then we have radar based sensors. So radar based sensors are nothing but it emits microwave pulses. So just like your military radars, but these satellites work. Military radars are on ground, and these radars are in space on a platform which is moving, and they emit microwave pulses and the backscatter, the reflected part, which the terminology for that is backscatter. It captures, and what the amount of signal it captures, based on that it creates a image. So mostly these sort of satellites are for defense purposes, because what these satellites are capable of, that they can penetrate the ground and get you information beneath the ground up to 5 centimeters beneath the ground. You can get the information from these sort of satellites. So most of the satellites, radar satellites which are in the polar orbit, are specific for military use only. Those are not available for civilian uses. So these sensors are named as SAR sensors, synthetic aperture radar. Then we have another form of sensor that are laser based sensor. So just like radar based sensors, these sensor emit laser pulses, and according to the bounce of signals, they try to create a image using that. One of those sensor, I would say, everybody's know about the International Space Station. So on the International Space Station, there's a laser-based sensor known as JEDI, which use this sort of technology to get the height information of the features which are present on the Earth. So it's a laser-based sensor, and these are called LIDAR, light detection and ranging sensor. So most of the lidar sensor nowadays are being used in mostly this aerial or airborne platform, because the point density at, because it emits laser pulses you can say these sensors are capable of 1 lakh pulses in 1 second. So if you fire from space, so you get a very limited range, because if your satellite is in polar orbit also, you will get a very limited range. So that's why these sort of sensors are mostly seen in aerial platform or UAV platforms only. Now we will move on to the true color and false color. So true color is normal RGB image that we use in our day-to-day life. We capture it via phone, we capture it via webcams of our laptops, or any other device captures only RGB spectrum. But satellites, these UAV platform, these aerial platform are capable of capturing many bands, and using that we create a false color imagery. So false color imagery is nothing, but we replace the RGB in the RGB spectrum. What we do, instead of using the red in the red band, we give red as NIR and subsequently change the bands below that. So in the blue, it's in the green, it will be red, and then in the blue it will be green. So using that combinations, we will try to create a RGB or this false color composite which we use. So in the false color composite, what happens that various sort of features get highlighted. Particularly vegetation is one of the features. As you can see, the vegetation here is shown as red, dark red and maroon. So it's basically how much healthier the vegetation is, the red color intensity is getting darker, and this particular patch, if you see here, is very very dark, because this particular part has a high amount of chlorophyll, or a healthy vegetation is this. So this imagery is from Sentinel-2, and this area that is the Indian Forestry Institute of Research in Dehradun, FRI. So this is the very famous scene. The Student of Year movie was shot here. So I have kept it for your reference here. And if you can see, these concrete buildings are being colored as cyan color. And this is a river, Ripsana, but it's a dry river. So the river bed is also being shown here as cyan only. It's because the reflectance of that particular feature and the reflectance of this particular feature are almost equal. That's why this sort of color is being here. So you can see here are a very light green sort of buildings being seen here, because these are of different materials. So different material behave differently under the conditions of life, or you can say under different bands, features act differently. Now we will go to the data processing part, like how being data is processed here, because we need to ensure that the data that we are using is reliable and it is of good quality. So how we get there? So first step is cleaning and correction. So this particular phenomena that happens in hyperspectral only, that when we capture the information, we have some bad bands. So bad bands mean the information is being absorbed by atmosphere, because if we go to the spectrum of electromagnetic spectrum, in that in certain wavelength regions the information is totally absorbed, and the bands or the image that you get is very blurry, or you can say completely pitch black. So no sort of information can be retrieved for there. So those bands are useless and they need to be removed, because if we process those bands, in the end it will create a data anomaly, and the result that we are expecting, we won't get that. So that's why we need to remove those bad bands. Then filling gaps. So filling gaps here means, what happens sometimes, some particular patch in the imagery is not captured. So the you will find very small patches a big black patch or very small tiny black patches which contains no data values, NA values in that. So those values need to be removed. So removing those, what we can do is we can apply a kernel filter. So kernel filter is nothing but you can use the neighboring values and make a substitute value for that particular part. Like if you use a 3 by 3 filter, so what you do is create a grid of 9 and place that particular pixel which is missing the value as a center pixel, and using those 8 pixels surrounding it and create a value for that and fill that pixel. Then another method is a line average method. What you can do, in which column or which row it's located, you can average that particular row and fill that particular the average value as the NA value which the pixel it's missing. So that's how we fill the gaps. So it's very important, because if the values are not being filled in these pixels, then the model we are trying to build, it will be a biased sort of, because these no data values will introduce a anomaly, or we can say a redundancy pattern that I will introduce after the in the spatial modeling, and the aligning rectify the alignment error. So what it this sort of error is more prone to airborne platform and satellites, because they are moving in the space and the speed is very high for those. So sometimes it happens that there is a blurry patch, or you can see the imagery is tilted to some extent. So we need to identify that particular part and rectify and align these patches with the upper part of imagery and make it a uniform sort of matrix or uniform sort of patch. So alignment error is also like one of the most common errors that we get, but it is very easy to remove that. There are various sort of functions and software that can do it on a very quick go method. Then mosaic is another part. What When we capture data, mostly this happens in the aerial imagery or UAV data imagery. That then we when we capture a particular part, so we get multiple imageries of that certain part of the area of our interest. So we need to mosaic and create a uniform imagery of that particular feature. So in that we have multiple methods. So two common methods that we use are pixel based and georeference based. So pixel base means here, when we capture these imagery, we have overlap. So overlap here means that when we are taking multiple imageries, these imagery will have a common part. So according to that common part, the pixel based mosaicing technique will try to make a uniform imagery out of those all imageries that have been captured here. Now we the georeference based technique. So in this technique, what happens that every imagery that we capture using UAV or like airborne platform, aerial platform, or satellite platform, these imagery have a particular lat long assigned to each and every pixel. So according to the pixels common in the other part of imageries, these imageries are being mosaic. So every pixel is assigned a certain values. So according to that, the georeference technique works. Then there is another type of mosaic, that is temporal based mosaic. So temporal based mosaic here means that if you have a time series data, so time series data means here, if I grab the data from the Sentinel satellite of 16, 17, 18, 19, 20, for 5 days I am collecting this data and merging this all data into one single data set. So that is what we call as a temporal based mosaicing. So mosaicing all the time series data into a single data set. Then we have a atmospheric correction. So this sort of technique is applied to mostly aerial or airborne platforms and satellite based platform, because what happens when the reflected light that these platform captures, so these light rays are attenuated by the atmospheric conditions. So sometimes it happens that the correct amount of illumination is not being represented in the imageries. So this sort of correction is applied here. So UAV data are excluded from this, particularly because mostly UAVs are flyed at a range of 60 meters, 120 meters, and at max 180 meters. So at that level the atmospheric disturbance is not that much. You can still perform it, but it's very unnecessary to alter the values. But in the aerial and airborne data, and particularly satellite data, this sort of correction is required to get a perfect illumination for each and every pixel according to the values which were currently present at that moment. So in this also we have certain methods. So there is a relative method. So relative method is nothing but just trying to simulate the actual values, or you can say we are trying to adjust the contrast, brightness, intensity, hue, and these sort of parameters to just replicate what would be the actual values. So the results in this sort of techniques are not very exact, or not very actual to the real values. But in some condition, when you have a very little amount of time, or you don't have that much computation power at your end, so these sort of techniques are then being used. But most accurate is the absolute method. So absolute method is nothing but they actually use the physical parameters for particular scene. So in the physical parameters, like what would be the altitude of satellite, or what would be the mean sea level of that particular area, humidity conditions, precipitation condition, and various sort of parameters are being used to correct the image that is being captured by satellites. So most of the satellites imagery that we use today give you a atmospherically corrected image, but still there are some satellites which don't provide you with the atmospherically corrected imagery. So in that condition you have to perform this atmospheric correction and get the desired output that you are waiting for. Then we perform a spatial analysis. That's the most interesting part, which we also term as data exploration part. So in this we have to focus on areas, particularly the feature or the patterns in the geographical data. So for example, the data I have shown you of that FRI, in that you can see there are multiple features: the urban feature, the vegetation feature, the river is there, the dry river bed is there, dense urban area is particularly in that imagery. So we need to identify which sort of feature or the pattern we are after. So for me, if I am working on urban analysis, so what I will be focusing on: the built up, the concrete material, or the material which are being used for building structures, or you can say any man-made feature. So that you need to decide which sort of feature you are after, or the pattern you are after. Then there's another thing, that these features, one feature will be having influence on the another feature. If a particular part of land is covered with vegetation but it is located in a dense urban area, so the vegetation would have a effect on that, the vegetation would be affected by that particular urban area, because this urban heat island is a concept in which we calculate the heat accumulated by all the concrete structures or the man-made structures. So according to that interactions of one feature with another feature, we try to calculate a certain spatial analysis, or like we can do various sort of planning based on these features. So taking a feature into consideration or a phenomena is one of the important part in this spatial analysis, because if you try to do analysis on multiple features, one of the things that you will encounter is trying to build a hypothesis for linking those features. So whenever trying to build a hypothesis, take one feature at the moment, try to relate it with another, and that feature with another features. Try to create a chain of this hypothesis building. Then the relationship would be established in a better form. Then we try using those special analysis, we try to model something. So modeling here is trying to model a real world phenomena that is happening around us. So there are also key points in this also. First, when you are building a model, so you need to take a specific area. So specific area means here that you need to make a buffer zone. So this is my area of interest, and according to that I have to do the analysis. Because if your area is too big, you will get the values or the analysis result very odd, or you can say it would be very incorrect. So these patterns need to be studied very closely. So buffer building is one of the main criteria here in the spatial modeling. So spatial modeling, I would give you example like a flood modeling simulation. So when we do flood modeling simulation, we try to first assess the land changes in a particular area. So if I take for Delhi, I need to first analyze like how much area comes under the built up zone. So because the recent flooding in the Delhi was very prominent. So I need to first calculate like how much built up area is particularly in that moment, how much amount of he, I would say like traffic. So I have to analyze that particular amount of transport management. I would say I need to do a network analysis first of all. Then I will try to simulate using that the network analysis, that how much areas comes under the roads or the urban locality, and try to simulate a flooding model using the SAR data or even a multispectral data. That can be done, but SAR data here would be very much beneficial because it will show you the changes very efficiently because of dielectric model. So dielectric model is nothing that every feature on the earth has a ability to conduct heat, but there's a constant limit up to which it cannot conduct electricity. So using those particular features, we can create a flood simulation model. Then example, I would say the urban analysis, that how the cities are expanding and how much agriculture area is getting reduced day by day. So that can be built under land use land cover change model. Then you can monitor like yield estimation is another part. You can use temporal data to predict yield of a particular agricultural field. So various sort of phenomena can be modeled using the spatial model technique. So and lastly, I would suggest the time period evolution of particular area is very important when you are modeling phenomena, because in a certain amount of time these features get evolved at a very rapid rate. So you need to consider the temporal stack of that particular feature to model it. So that would be another part. Then what you guys are like, maybe some of you know, but most of the insurance companies now in India are using geospatial services, as in like these companies will send you alerts based on your location. Like if you are in Mumbai, so they will like they will send you this flooding, about flooding events, about cyclone events, about any sort of if there is a terror attack or any sort of geospatial information that it gets, it will try to send it to their users, not to protect the user, but to reduce the insurance claim. For example, there is a hailstorm in Mumbai, and and your card is insured, but you are under the hailstorm attack and your cards get destroyed. So insurance companies had to pay to you for this sort of event. So to try not to give these sort of claim, they use geospatial services and inform the users accordingly. Indian government is one of the leading adopters in this domain. Like income tax is one of the early stage adopters, I would say, in using geospatial services in their daily routines. Using these geospatial services, what they are trying to analyze is the the land part. If a X person has certain amount of land registered is his name, and this land is transferred to another person, but there's no record or there's a misleading trails of evidences against that person according to that land or some particular area that is locating here. So they are trying to use these sort of services to verify those claims or to try to incorporate this sort of model for further correction in their system. Then your smart city planning, the smart city planning is also being done using these sort of services only. So they do a network analysis using the shape files, or we can say that line features are mostly your roads, your canals, and these sort of things, and accordingly they try to build a model for smart city planning using these geospatial services only. Then comes the validation and reporting part. So in validation, you have a particular finding, but how to confirm that your findings are valid or not? So first is very common is a visual inspection, that you get a result, and from seeing that result, you are sure that that particular uh, data you analyze and you build a model around it, and the report that you are getting is good or not. So visual inspection is like verifying it yourself, is first part. Then you need to cross validate. So for uh, example, I have done a analysis on a vegetation. So we can take example of rice vegetation or paddy crop. So I'm getting the values beyond the outliers. So the range lies in the 0 to 1, but I'm getting the value of 1.2 or 1.3. So I need to cross validate my claims with any sort of other claims. Like you can do a literature review for that. So you need to cross verify that results that you are getting are correct or not. It Are they in the safer range, or you are getting like way beyond the outlier range. So you need to cross validate with the previous studies. So a thorough literature review is has to be done. At least like you when you are doing an analysis or you are building a spatial model, it is recommended that you read at least 10 literatures on that specific topics, so that you get a thorough understanding of that of the spatial modeling or like validating your claims. Then there is a part which we call verify with the ground truth. So your model has given you a analysis, a imagery that is highlighting wheat fields. To verify that claim, you need to have a ground information. Is that the fields that are being highlighted by a model is actually wheat field or not? Because sometimes it happens when you're trying to model these sort of things, what happens that another crop which is very similar to wheat can come under the classification part it as a wheat only. So you need to have a ground truth information, that if you are identifying a feature for X field, so in the X field where that particular feature is being located. So you need to verify your claims with the ground information. So you need to have a ground truth. Then there is a peer review, what you say. So you can share your findings with the experts, or even professors or any industry expert, any domain expert, I would say, which can validate that yes, these claims that you are claiming are true, and this can be further used for like research purposes, for product development, or any purposes that can be used. So these sort of parameters you need to follow when you validate your findings. Then I talk about track selection. So earlier, so track selection, here we have two tracks. First is the research track. So in the spatial industry, people are segregated more in the domain of research. So we have researcher more rather than the people in the industry. So these people are like, they publish articles, they publish research paper, book chapters. So when you are building this sort of spatial model or spatial services, you need to select a track, like in which track I have to go, in the research track or the in the industry track. Because when you go to the research track, the things change, changes, because you can publish your article, research paper, book chapters, but this information will be open source to everybody. So you won't be getting any monetary benefit for them, but you will be getting like a recognition at a global level for this sort of research or publications that you publish for your research. So in that you can make a tool for this model, that if tool, like I have if you give satellite imagery to that model, it will give you a urban change analysis model, land use model, anything that you use case around that. So that can be done. Or you can collaborate with other researchers, like you are working on a model like a CNN model that will identify wheat fields, and it will try to estimate what sort of yield prediction would be in that particular season, and how much area is being covered under the wheat field. So this sort of model you are like trying to build. So what you can do, like you can collaborate with other fellow researchers and trying to scale this for not just only for wheat, for more crops as well. So that can be done in the research track. When you go to industry track, that things are changed. So you can what you can do here, you can provide your model as a service to other clients, that you have a particular model that will do perform a particular use case, that can be anything related to urban, to environment, to transportation, that can be done. So you can provide it as a service, or you can take up a different project from a particular stakeholder, and then you can do the analysis part and report that part to the stakeholder. Then there's a part that you can file for a patent here. So you have created a model and you think that algorithm is very different, it's very efficient, then you can file the intellectual property registration for that, and you can claim a patent for that. That can be done as well here. So another fun fact here, the man companies uses geospatial data but won't tell you. Very, very true. Like Google is one of the biggest consumer of the geospatial data. It gets data from from Boeing, from Airbus, from Maxar. Every sort of data Google is having, location based, imagery based, document based, coordinate based. So they have lots of geospatial data. Because of that only, it is able to provide you location based services at very, very quick speeds. Or you can say they are trying to build a 3D 3D maps. So 3D maps they are trying to build using these technology only. So this leads to a second giveaway here. So name the technique and technology Google use for 3D map generation in the YouTube comments. So you have to just name the technique. What is the technique and technology stack? Even if you mention single technology or multiple technologies, it's it's very well understood in the YouTube comments. And here the one thing that I have done differently is chat GPT is allowed. So you can use chat GPT to get your answers. So it's just a finger fastest one. So whosoever answer the quickest and the most accurate is the winner of the giveaway. Let's move to the most interesting part, which I call the implementation via the open source GeoTech. So in this, I will tell you about the open source technologies, because they are various softwares that we use in industry, but they are very costly software, commercial softwares. So an individual cannot afford their software because they cost very high. So they are good open source software which can get you started in this sort of industry, and it's very good. They are very good. No problem, you won't face any problem, because the community support for these software is so good that you post the answer, and in minutes you will get you post the question, and you will in minutes you will get the answer for your particular query. So community support is something that is very good here. So first we will talk about the open source data portals from where you can get this sort of geospatial information, particularly the image information. So USGS is of American agencies. So they provide you data in the form of lidar data, what I talked about, in the form of SAR data, and multispectral data and hyperspectral data. So all sort of data is available with them, and you can readily download it. Just you need to create an account on USGS. When you Google on the Google, type Earth Explorer USGS, and you are good to go. Create a account, and you are like in the server itself, and try to download the data on the go. No problem in that. Then it's Copernicus. It is of European Space Agency, for the Sentinel series of satellites. So we have Sentinel-1 for SAR, for Sentinel-2 for multispectral data, and Sentinel-3 for thermal remote sensing data that can be downloaded free from the Copernicus portal, which is owned by European Space Agency. Then you can download remote sensing data of Indian satellites from Bhuvan. You have list 3 data, you have cartosat data, and other data as well, from like Everest NG, ISRO, NASA camping data is also available on Bhuvan. It's a airborne data, very fine data of 3-meter resolution. You can download that. Then Google have its own search for downloading geospatial data. So you can go to Google data search, and there you type the if you type UAV data, so it has collected various links of UAV data, or any data. You can even download Sentinel data, you can download Landsat data, any open source data which is available there. Google data search will lead you to that link. Then there is NASA Earth data. So it has various satellite data, like high resolution satellite data, like world view, and even lidar data of airborne campaign is in the Earth and data repository of NASA. So these are some portals from where you can download open source data. No problem, just create an account and you are good to go. Nothing else is required. Then we will talk about the open source software. There are people that who don't want to write code, or they just want to have the softwares available with them, and want to process the data and get into the geospatial domain, but coding is not their thing, or they are not good at coding, very mediocre. So we have open source softwares. In these softwares, you don't have to code or program everything. Just put the data, do your analysis, and you are good to go. So QGI is one of the best, which I use daily. Is one of the best. It's based on Python. You get every functionality here, and if you think a certain functionality is lacking in the software, it has plugin support and come in. So, and lots of people are there which develops plugin for this software, and it's very good, very reliable. They hold conferences every year, and you can publish your reports, like I am doing this sort of data, and you can go to that particular conference. They provide even travel grant for this. Then we have Grass GIS. It's again an open source. And we have Saga. So QGIS, Grass, and Saga, they comes in a bundle. So when you install Q, you get all three in one. So you can use either one of them. These all three are good. Saga is particularly very low on computation cost, or if you don't have a system that have very high end spec, you can opt for Saga. It's do things on the go, very automated process. Nothing is required to be done here. Then we have Cloud Compare. So we, like I was talking about the data, the laser based data. So Cloud Compare is again an open source software based on Python itself. So here you can process all your lidar data, laser based data. So these sort of lidar data or laser based data, you can create very good 3D models. In that, a 3D fly through can be done, a 3D representation of particular structure is done. You can do a heritage analysis in that. So various sort of things can be done. Cloud Compare is a very good software for that part. So we have Snap. It's a very good software for processing your SAR data. It's very good. It's again owned by the European Space Agency. Open source, Java based, good to go software. So the people who are in the front end, like I'm a front end developer and I want to engage in the geospatial domain, like how I can get into enter. So we have technologies that can cover you, and we have Leaflet, OpenLayers. So these are all JavaScript based libraries that you can use, and you can create very good like apps using these libraries. Even integrate these libraries in your already made projects here. Then we have GeoServer. So GeoServer is like you can use it to store your imageries, images. Like if you download one imagery from the of Sentinel-2 from the Copernicus portal and you want to host it, so where do you host it? So GeoServer is another server that you can use, and you can put all these images and host these in the real time. Good to go. Nothing is done, just plug and play thing. Then many people use Postgres SQL as their backend for storage. So it has a extension called PostGIS to store all sort of geospatial data. Even it's in vector or raster form, doesn't matter. It will store you for that. So it's a SQL based server for storing geospatial information. Then OpenStreetMap is here. So OpenStreetMap is nothing but like you can say a alternative to Google Map or even Bing Map. So Bing Map is based on OpenStreetMap only. Here you can contribute that if you want to create a particular feature that is located in your locality, and you can create that particular feature in the OpenStreetMap itself. It's very good. It's crowdsourced, it's user based, very good alternative to Google Maps. Then the people who are in the 3D designing and want to make a 3D model using geospatial imagery, cesium is one of the Java based library itself. You can use this, sorry, JavaScript based library. You can use this to create very good 3D model again here. Then Blender again have a very good extension that we call Blender GIS to creating 3D models and 3D simulation using the geospatial data. So that can be done here. For the people who are in the machine learning, the deep learning domain, and want to get indulged in this geospatial domain, so so we have technologies for them as well. Jidal is one of the libraries. Using that, we write, we analyze our this raster form of data. Then we have GeoPandas. So it works as the normal pandas that we use in the ML or like in the Python part, but it this GeoPandas is able to read the geospatial information which contains the lat long part also in the data. So GeoPandas is the replacement for the pandas here in the geospatial domain. Then we have GeoLambda. So GeoLambdas are the AWS servers which contains almost every geospatial library. So they are good to go servers. You can use them for your deep learning parts. Many of my friends use GeoLambda for doing their geospatial analysis on cloud. So that is for those people. Then you have Torch Geo. So many people use PyTorch as their backend in this Python deep learning model creation. So GeoPanda is GeoTorch, sorry, is like GeoTorch, Torch Geo. You can say either way, is particularly used for satellite data image analysis, UAV data analysis, or even for your airborne data analysis. So this library is specifically optimized to use large size geospatial data. So when you download a satellite imagery, so one scene from the Sentinel-2 will be of 2 to 3 GBs according to the resolution you are opting. So 10-meter imagery can be up to 2 GBs for a particular scene. So Torch Geo is very optimized, very handy, good to go library for using on satellite data. Then we have TorchSet. So TorchSet is one of the libraries that use YOLO, VGA16, your UNet, your ResNet, your DenseNet, AlexNet, GoogleNet. All these sort of architectures are pre-programmed here in this libraries, and you can do segmentation, you can do classification, you can do like optical recognition. Everything can be done here in the geoset. It contains every like you can say models, your YOLO models. These sort of models are being here, and they are tweaked accordingly for this satellite data analysis only. So the satellite data, UAV data, airborne data, the data are like similar, but the resolution is changing. On satellite data, you get a coarse resolution of 10:5. On airborne, you get a 3 meter, 1 meter, even centimeter level. On UAV data, you get a very fine resolution up to centimeter. So resolution is changing, but these sort of things can be used on any library. You have Geoda. So Geoda is again a very good library if you are going after the geospatial deep learning models. It has segmentation, classification features, features ready to go. Nothing else is required. Just give your data, call the function, and it will do the analysis. If you want to code it and tweak it, you can tweak the hyperparameters and good to go. Nothing in it. Now you want to create an app using uh, this all the simulation that you have done. So Streamlit is another platform that you can use. It goes very well with the Python models. So you can just plug and play and just accordingly set the various function to various features, and it will make you a backend on its own, and you can make a Streamlit app that can be hosted anywhere around. Nothing needs to be done. It's very good. Then let's talk about some use cases, like for agriculture particularly, which I'm like currently working on, is the crop health analysis. So we use this uh, UAV data here at BharatRohan, and we try to do a crop health analysis and try to inform the stakeholders accordingly. Then we use it for irrigation management. How much amount of water is particularly required for that crop is again done using UAV data only. Then we give our prediction that how much yield if you follow the advisories that we provide to the stakeholders when you opt for the services at BharatRohan. So we also give them a yield prediction here. So these are some use cases that I am currently working on in the BharatRohan in the agriculture domain. Now in the urban, again, smart city planning that I was talking about, the network analysis that we do using the satellite data. We plan accordingly from which part of the data, how the bypass or the highway or these interconnecting roads, underpasses, all these things are need to be designed. So all these are done using geospatial data. Then your environmental monitoring. So You might heard that government is planning a tree plantation drive, or sort of environmental friendly guidelines. All these are made using this geospatial data. They analyze data for a particular patch and try to estimate how much built up is there, how much vegetation is there, using different techniques, and try to build policies using that only. Then again, transportation management is comes under this smart city only. Network analysis can be done for each and every roads. Then what I would suggest the people who are trying to indulge in this domain, try Google Earth Engine. So Google Earth Engine is a platform, online platform hosted by Google on its cloud platform, which is Google Cloud Platform. In this, you get, first of all, it's a cloud based, so don't need very high end system or resources at your end. You don't need a very high end infrastructure at your end to process the data. It's cloud based. You get a very high amount of compute directly. Then the data access. So Google Earth Engine provide you data from Sentinel series of satellites, from Landsat series of satellites, from various satellites. They have collected uh, data from very beginning, and from the for the current date, for today's date also, they have data on their servers. So they get directly from the data from these servers, and try to do analysis on their own, and also provide this data for users also. So they have very high, I'm talking about in petabytes, guys. So in petabytes they have data. So very large amount of repositories you get here at in the Google Earth Engine. Then collaboration and sharing is another part. Like you and your friends are working on this particular project which is related to geospatial domain, so you can collaborate in real time. Like one of the like your friend is working on some part of the app, and another is working on some other part of the this project. You can collaborate in real time. Nothing is required, just you need to give access to that particular user. So all is done in real time. Collaborating, sharing is very easy. Then machine learning integration. So you can integrate various models, like you can readily use TensorFlow, TensorFlow, JavaScript, which is you can use it, and you can build a CNN RNN model. So JavaScript version of TensorFlow can be used here for any machine learning, deep learning part can be done here. Random forest, SVM, your general machine learning models, your deep learning models can be built here. So it's one of the good platform if you are trying to engage yourself in the geospatial domain. Like just try to visit the Google Earth Engine documentation first, and try to grab as much of information, and try to build various apps. You can make apps and you can publish it. No costing is required, no fees is required. It's just you need a Google Gmail ID and you are good to go. It If you are front end developer, if you are machine learning enthusiast, or you are very new to this geospatial domain, I will highly recommend you to this platform. Just go and try to explore the documentation, and try to build a nice app that you can use for any sort of, as a product development hackathon, or any sort of event project you can do. Just explore this, very good. Then we are coming to the end, and summary, I would summarize this session as: the geospatial data analysis is a powerful mechanism that unravels a deep understanding within the geospatial context. By harnessing its potential, as this approach offers insights that drive innovation, contribute to informed planning, decision making across diverse domains. So that's what I would summarize this session as. So for your references, I have made a QR code. You can just scan it, and I have listed various sort of books, links, YouTube playlist, even GitHub repositories, which contains very large amount of resources. So you can scan this QR and you can look at those links. They are very good. I have personally used many of those in my this post graduation phase. I've used these, and I'm very much satisfied, and like I've made various projects using these resources. So I'm sharing that things with you, so you can get a good idea how to indulge yourself in this domain. Then I would like to thank the team at Hack the Mountain for giving me this opportunity where I can share my thoughts with everybody here around. Then I would like to thank our co-founder and CEO at BharatRohan, Mandeep sir, for allowing me for the giveaway part and giving me all the infrastructure and the support from the BharatRohan. Then I would thank Shifali Garg, my friend at ITC Netherlands, for all the styling cues, for adjusting the flow of this presentation. So I owe a big thanks to all of you. Thank you guys. And you can connect me on LinkedIn. You can type straight away my name, HarshAditya Gaur, or you can email me your queries. Like I would be very happy to answer all these questions. And I occasionally write on Medium as well. So there also you can connect with me. So thank you guys.
Thank you, HarshAditya, for this informative and enlightening session. On behalf of all the attendees and the organizing team, we extend our sincere gratitude to you. To all our participants, thank you for your interesting engagement and thoughtful questions. Your curiosity and active participation have made this session a success. Stay tuned for more details on HTM Qubit session, and we look forward to having you with us once again. Before we conclude, I want to say that the learning doesn't stop here. It's a continuous journey. Thank you for being a part of this enlightening evening. Thank you all for your time, your insight, and your curiosity. Until we meet again in our next section, take care and keep exploring. Thank you, Harshavitra.
Yeah. So the people have like questions, I think. Okay.
Yeah,
First comment, I don't think transaction ID is a form of geospatial data. Is it using to identify? Okay, ठीक है. And then, yeah, or it can be if it has a transaction in the geospatial domain, uh, okay, let's announce the winner of the giveaway here in the session. Okay, okay. So Shanaya Agarwal, I think you have answered it very well. The combination of advanced technology, aerial imagery, SAR data. Okay, okay. You have answered it very well for the second question of my giveaway. So it's a combination of technologies, guys. So what had happens that Google use stereo pairs. So stereo pairs are nothing. You have two imageries of a scene, but overlap. The common area is more than 75% or 80%. So using that imagery, there is a technique called photogrammetry. So using that technique, what you can do is you can derive relative height of the features in the imageries, and using that you can build 3D models. So Google has very large repository of geospatial data here. So using that, they can like build 3D models very easily because they have compute power, they have data. So all they need is to develop a technique, and technique is very available, just it needs to be tweaked accordingly. Then you can generate the model here. So I think Shania, like you can DM your details to the Hack the Mountain community, and like we can arrange the mystery box for you as okay. Then okay, nobody has answered about like transaction ID. Okay, I have seen that is associated with a physical location such as land. Okay, okay, guys. So I think like I need to answer this question. So your transaction ID. So transaction ID. So when you do a payment, so what you use a IP address, Internet Protocol address. So every IP is linked to a particular geolocation. You type your IP on IP locator, type your IP, and you will find a corresponding lat long to that particular IP. So your transaction ID is a form of geospatial information, and using that information, people are building a transportation system. They are like building infrastructure in your community. So imagine there's a like place in Nehru Nagar, and they are transacting amounts in lakhs, and there are people like 1 lakh people, and their spending capacity is very high, very high. So this data is being stored on your like the payment gateway or the payment app that you are using, and they use this information to the third parties. They sell this information to third parties for their use, and what these third parties do, accordingly they plan their infrastructure, their product services, their marketing services, many services which are location based. So your transaction ID is actual form of a geospatial information because of the IP address that you are using, and it is corresponding to a lat long. So try to search it around. You will find more information on that. So I think Sujata has tried to answer this question. So Sujata, you can also like DM your details to Mansi, and like from there we can like send you on the mystery box here. Guys, one thing more is that it will take time, like 20 to 25 days at least, to ship this sort of all the swags to you guys. Okay, so I will ask you to just have some little amount of patience. So we will just send you those. Okay, so then another question is there. I have experience with ArcGIS. Can I switch to QGIS? How different is learning curve? So learning curve is not very different. Like if you know the ArcGIS well, you can switch to QGIS, and I would like really appreciate this move, because you in the ArcGIS, first of all, it is a closed source software. It is based on Python 2.7, which is absolute now. So if you move to QGIS, you can integrate your machine learning or deep learning part very easily, because it is based on Python 3.7, I think 3.8, and you can do directly, just type things in the console when you do your analysis part. So you can do it very easily. So learning curve is not very different, but the only difference is the terminologies are different here in the in the QGIS. For in RGIS, for say you have to reproject something, so you need to type reproject. In QGIS you need to set layer CRSs. So terminologies are different, but things are same. Like very good move if you are switching to that. Then I think nobody has asked any question here yet. Okay, we have another question. I sort a question. Okay, I have seen difference in Google, like this is very real, but India is not. Okay, this question very interesting question, and I think you would get a giveaway for this, because to answer your question, India has restricted the data in for the Indian continent. Indian government has restricted the Indian data capturing for the Indian continents, because according to the current policy, they cannot allow freely open source data cannot be allowed more than 3 meter level. So that's why if you go to Google Earth Engine or Google Earth, when you scroll the timeline, you get past data, because they have asked Google to remove all the high resolution data available for Indian continents, because they won't allow free available data. So that's why. And clarity part, because for this Indian continent, you need to get the lidar data. Getting lidar data is very difficult. Very Government won't allow you to do a lidar camping. In the US, they have lidar data for almost every state, I think. So that's why this Google Maps is very clear, because what they do, they generate a 3D model and overlay the imagery, satellite imagery on that. So accurate representations of the objects in 3 dimensional can be seen there, and high resolution imageries they have from Maxar and Boeing. So that's why the clarity is very good, because high resolution data policies in that particular part of continent is very linear, and here in India it's very restrictive. So that's why it's the clarity part is very different. I think that answers your question. Then any question? I think interesting question. OpenStreetMap cannot get accurate names of my location. See, OpenStreetMap is totally user based. So sorry guys, I had an internet connectivity issue. So OpenStreetMaps are almost like user based. So user put information in those features, so that's why you won't get very accurate results in that. But the community is slowly increasing for OpenStreetMaps, and slowly the this OpenStreetMap will be a exact alternative to your Google Maps. Like it will be very close opponent to that, because your Bing map is totally based on OpenStreetMap itself. So you need to like contribute. I would like suggest everybody, so you can contribute and make the improve the accuracy of this OpenStreetMap like to a higher level, to make it goes to a higher level. So try to contribute. Okay. So why do you feel that the Map My India, where it's feel about Map My? So Map My India currently is trying to provide 3D maps. So to give you an example of this, you are going from Delhi to Gurgaon, and you need to change a lane. So Google Map won't tell you about lane changing, or there is a flyover through that to another lane, or that particular lane is going down. It won't tell you. It will just ask you to go straight. But Map My India, what they have done, they have made 3D mapping, and they will guide you. Like you need to take flyover, you need to change lanes, you need to stay on the elevated road or on the ground road. They will tell you about these sort of information. So I think they need to just promote their products more, because currently many people, like most of the people are, yeah, like using Google Maps. So I think government needs to play a role here to promote this Map My India as an alternative to Google Maps, because like I am using Map My India maps since I think 2013, when the car navigation was very new in India. From that period of time, I'm been using Map My India as services in my cars. So they need to promote their stuff. Like they have good services, but the promotion and marketing is not done very well. That's why that's the domain where they are lacking right now. So if they promote, I think they will give a tough competition to Google Maps in India. Yeah, each one is using see, using Google Map for a commercial part will charge will cost you more, because Google knows that they have a very accurate product, because the accuracy of Google Maps is in centimeters, while the other products in the market have accuracy of meters. So that's why they play a monopoly here, and they charge more here. So the products which are very new in the market, they are using Map My India as an alternative. But in the future, we can see many products using it as a like an alternative to Google Maps in their location based services. It can be like done, but they need to like promote the marketing and products way. So I think somebody asked about the if I'm scrolling comments, false color imagery are generated. Okay, so false color imagery is nothing that you just replace the this band. In the RGB you have red, green, and blue. So what you do, you replace the R and put the NIR in the R filter. Then what you do, you put R in the green filter and green in the blue filter. That's how we generate the false color composite here. So another question that I find is mm, okay. So okay, any more question, guys? Like, we have still one mystery box left. So if you guys want to like win it, so we have one still left. You can post your question, like, or else we can end the session here. So Sujata, you can you try to answer about the this geospatial ID. So you can DM your details, and Gaurav also, and Shanaya Agarwal also. Like, another question I'm expecting here for the giveaway. Okay, guys. What we can do here? Uh, Go on the Twitter page of Hack the Mountain, and there you can just uh, like uh, give me a use case, like what would you do if you have a drone at your disposal, what sort of use case you will target. So you can simply reply on the post of this session in the comments, and use hashtag HTM 2.4 HTM QuickBits, and tag hashtag BharatRohan. In that, tell me the use case, but this is valid for the users who haven't won the giveaway prizes. So they can go there, tell me a good use case, and I will pick a winner from there. So guys, okay, I can't see any more questions, so thank you for this session. Okay.
Thank you, HarshAditya, for this informative and enlightening session. And thank you to
Okay.
all the participants for their interesting engagement and thoughtful questions. And stay tuned for more details on STM Qubit session. And we look forward to having you with us once again. Before we
Yeah.
conclude, and thank you for all your time, your insight, and your curiosity. Until we meet again in our next session, take care and keep exploring. Thank you, Harshaditya.
Thank you. Bye bye, guys. Have a nice day. And